I had gotten emailed a number of homework questions, so we'll spend some time looking at homework questions. If your homework went fine and you just want to zone out for a little bit, that's fine. So the first one I got emailed was this one about time, and the time is previous instead of later. In class we looked at how far we'll be if time goes later. So, did anybody have problems with this one? Because then we'll use your numbers instead of mine.
Didn't you?
Yeah, but I don't remember what I did.
I actually got that because what you do is you minus instead of adding anything.
So on this clock we are at 4:45. So I'm going to draw a clock, and I think that actually helps. For me it does. I can picture it. And we're starting at 4:45. So I'll put the hour hand on 4. And my first question is 24 hours earlier. So 24 hours earlier, well, that's one whole day. So it still will be 4:45. I'm not going to write the minutes on the clock, just the hour, because the minutes will stay 45. 3 hours earlier. With the clock picture you can count, so I recommend drawing a clock picture and counting, so you can count 1, 2, 3, so 1:45. 29 hours earlier, you'll need to take away multiples of 12, so whatever your number is there, take away multiples of 12, because every time 12 hours go around, we're still back at 4:45. So take away multiples of 12, and then we're down to 5 hours. So I really want to know 5 hours earlier, and that will be the same as 29 hours earlier. So starting with my big hand, my hour hand on the 4, 1, 2, 3, 4, 5. So 11:45. Then we're looking at 96 hours earlier. Not 96, 9,600 hours earlier. So now I'm going to do what I did in the last one, only on a bigger scale. So I'm going to take out multiples of 12 again, but I'm going to use the modular arithmetic that we learned to do that. I'm going to take 9,600 divided by 12. That turns out to be 800 evenly. There's no fractional or decimal part. So 800 times 12 is 9,600. So in other words, this hour hand is going to go around 800 times and be back exactly where it started. So the clock will still show 4:45. Does anybody have questions on that one? Okay. The other ones I had gotten emailed were 14. And this is a UPC code. And I'll just remind you how you do the UPC code. So I'm going to write it down with lots of space in between each digit. So 0, 2, 8, 5, 0, 0, 1, 1, 0, 7, 0, and then I don't know the last digit, so I put a box. So the pattern is to go, say times 3 times 1, times 3 times 1, times 3 times 1. So multiply each digit by 3 or 1 alternating. The check digit you can think of as times 1. Multiply all of those out and add the results. Now it doesn't, you're going to have different numbers than me, so you're going to have something different. But the question still is, what do you add here? And the way you figure out what you add is that you need to come out to have all these add up to be equivalent to 0 mod 10. So the checksum is all of these added up, including the check digit. So when you have problems that ask about the checksum, add everything up, even the check digit. Here I'd have 26, 31, 34, 35, 35 and 7, 42. Plus I need something more. And I need that something more to bring me to the next number that ends in a 0, so that I'm equivalent to 0 mod 10. So what would that be that I have here? 8. Yeah. So this one is 8. Because then I'll get 50 for my checksum. And 50 is a multiple of 10. And so it's equivalent to 0 mod 10. Any questions on that one? If you think like, I did that and it's just not coming out, make sure that you either double check the arithmetic, of course, and then email myself or one of the tutors so that you can see what happened there. Show your work when you do that. This one's a little harder because the digit in front is missing. So on this check code we have a missing first digit, 35888. So I'm writing them down with lots of space. 412 019. 35888. That's a thing you should check too. Make sure you wrote it down without making an error in your transcription. So this one's a little harder because the first digit's missing, and it needs to make a number that's a multiple of 3 that gives you a checksum that's 0 equivalent to 0 mod 10. So 3 times 1, 3 times 1, 3, 1, 3, 1. Times 3 times 1. We'll add all these up when we have them. And you have different numbers than me. But whatever you get, add them all up except for the first one. I have 18, 26, and 24. That makes 50. Here's 20. 1 and 6 and 3, that makes 10. And there's a 9. So I have 70, 89. So I wish I could just add a 1, but I can't. If I just added a 1, of course, that would bring me to 90, which is equivalent to 0 mod 10. But I can't add a 1. If I put a 1 up here, I get a 3 when I multiply. So keep going through numbers that add in 1 until you get a number that's a multiple of 3. And I hopped right to it. I should have tried 11 first. 21 is what I want to add, because 89 plus 21 ends in a 0. 110, and I can get 3 to divide evenly into 21. So I have a 7 here. So you have to think a little backwards on this problem. So the check digit is given, but the number in the front that you multiply by 3 is not. So you have to think a little backwards, figure out what your digit that you're adding ends in. So mine ends in 1, and then try 1, 11, 21, or if you had 2, 2, 12, 22, and keep going until you find a number that's going to have 3 divide into it evenly. Do you have any questions on that? I've also gotten asked 2 more questions, 20 and 22. So when we move to checks, we have a different checking code. So I'm going to write the check routing number here, 735 686 686 618. So for a check, we have a little different process. We multiplied by 7, by 3, by 9. So 7, 3, 9. 7, 3, 9. And again, if you think you did this right and it's not coming out, write it down completely over, because it's really easy to keep looking at the same error and not noticing it. So you have the same process but different multipliers. You're just going to multiply it out and add up the results, and the result needs to be equivalent to 0 mod 10. So in other words, it needs to end in a 0 there, whatever it is. That's how we would know if we had a correct routing number down. So I'm not going to go through the adding because, of course, you'll have different numbers. Do you have any questions on that one? 22. The second part of 22 actually had a error at Wiley Plus on it, so one of the students caught that and Wiley Plus fixed it. I've never had an error on Wiley Plus before, so that's not common. You don't have to think that's going to happen usually, but if this was wrong for you the first time, check and see if Wiley Plus corrected it. I'm not sure if they just corrected the student who caught it or if they corrected everyone's, but I'll be happy to look at your arithmetic and see if you made an error. I'm just going to go through one because this is a little trickier since we have that multiplication going on, and that instead of just a check digit that we multiplied by 1, our check digit here multiplies by 9. So I'll write this down. 7, 1, 5, 0, 5, 2, 7, 3, and something I don't know. Okay, so times 7 times 3 times 9. And sometimes it helps to just take out your calculator and look at the screen, and as you're looking at the screen, type it into your calculator what you're multiplying by, instead of doing the multiplication in your head. Oh, and you want to double check, right? I added there instead of multiplying. So double check and then add. And I don't have a calculator with me, so I'm going to add the ones places first. 12, 17, 22, 30, 39, 48. And now I add the powers of 10, 40, 80, 90, 100, 140. So I get 188, and I need to get something added on there that will make this have a 0 on the end. Okay. Nicholas, do you have a calculator with you? Could you please check my arithmetics? And then if I have it wrong, we don't have to have the whole class wait while I double check. Okay, thank you. And then we're going to add 2. 2 would be easiest, but I can't multiply 9 by something and get a 2. So now I keep going through numbers that end in 2. 12, no, can't multiply by 9 to get 12. 22, no, that's not evenly divisible by 9. 32, no. 42, 52, 62, 72. 72 is evenly divisible by 9. So 72 is what I want to have added on to the 88. So I need an 8. My check digit needs to be 8 because 9 times 8 is 72. Did you get 188?
It was 188.
Okay, thank you. So it's a little harder when you have to think backwards. Does anybody have any other questions that I didn't go over? Okay, send that basket back around. I don't want it to come home to me, all right? Please. All right.
My question's in another section.
Which section?
2.7.
Okay, so 2.7, I changed the due date because we're not going to get all the way through it today. And so you can hold off on questions for 2.7 until next week, okay? Any other questions?
don't have to do 2.7?
We're going to work on 2.7 in class,
Okay.
but the Wiley Plus 2.7 and the Canvas 2.7 activities won't be due until the following weekend.
Awesome. Thank you.
Okay. Yep.
I have to resubscribe.
Well, let's pick up where we were then in 2.7. We were looking at numbers and we divided them up. So we'll just review a little bit, since you do get asked about these different sets of numbers. We want to make sure you feel clear on what those are. Who remembers what is the definition of the real numbers? Yes?
All the numbers on the number line.
Good. All the numbers on the number line. So we have all the numbers on the number line, and those real numbers can be split up in a couple different ways. We're going to split them up into rational and irrational today. So all the real numbers can fit into one of these two categories. Rational, does anyone remember the definition of rational, or how you can think of rationals? Right, fractions, ratios, yeah, good. So you see that word ratio in there, that reminds you rational numbers can be written as fractions. So a rational number has a definition: a number that can be written a over b, where a and b are integers, and b is not 0. Okay, so you hopefully have that in your notes from last class. And then we have irrationals. And those are just real numbers that are not rational. Real numbers that are not rational. Or if you wanted, you could write real numbers that can not be written as a over b, where a and b are integers and b is not 0. But it's shorter to just say real numbers that are not rational. Well, we had our definition, but then we had examples. So the decimal expansion. The decimal expansion of rational numbers had one of two characteristics. Does anybody remember what the two characteristics could be for a rational number? Yes.
Terminates or repeats on the right.
Wonderful. Terminates or repeats on the right. So examples would be 3.2 for terminating. Thank you. Example would be 3.2 for just terminating, or repeating on the right, we could take 2.66666 dot 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 dot. So the 6666 goes on forever, repeating itself. Some real numbers that are not rational are irrational, and their decimal expansion does not have either of these characteristics. It will not terminate, it won't just end, and it won't end in a repeating pattern. So it does not end, doesn't just stop, and it does not end in a repeating pattern. So I'm going to give you an example of an irrational number that doesn't end in a repeating pattern. So how about 2.126? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, dot, dot, dot. Does anybody know what would be the next two numbers? Yeah, 14. So you can see it goes on forever, but it doesn't end in a repeating pattern. It has a pattern, but not a repeating pattern. Well, we're going to investigate why fractions end up terminating or ending a repeating pattern. Before we do that, though, we're going to look and see, well, how do you know if a fraction ends in a repeating pattern? Rather, if a decimal ends in a repeating pattern, how do you know what fraction that is? We already know how to find terminating fractions, how to write terminating decimals as fractions, but how do we write repeating as fractions? So let's go ahead and do that. And this will be a skill that we'll be using on your quiz, and you probably haven't seen it before. So if you have been kind of drifting away, bring your focus back, okay? How to write a rational number with a repeating ending as a fraction. So this is a skill to learn in this section, how to write a rational number with a repeating ending as a fraction. So we'll start with the number 42.01943943943943943, and now you have the idea. You can write out as many repeats of that as you like. So we're going to write that as a fraction of integers. In fact, I'll usually say as a fraction of integers. Okay, so no decimal, just one integer without, those are numbers without decimal parts over another integer. So here's the plan. We count how many decimals are repeating. So right here you have 943 is repeating. So find out how many decimals are repeating. Three decimal places are repeating. And so that means we're going to take and multiply our number by 1,000. We're going to take our number and multiply it by 1,000. Now we're picking the 1,000 because it has three decimal places. I'm sorry, 3 zeros. We had three decimal places repeating, so we multiplied by 1,000 that has 3 zeros. So the 3 and the 3. 3 decimals, we need 3 zeros in our power of 10. So we're always picking a power of 10 with the same number of zeros as decimals are repeating. So name your first number. Okay, we're going to call that number n. First number is called n. And now we're going to write down 1,000 times n. Now you can do this in your calculator if you want to. Just remember it goes on and on forever. I'm going to put real big. Don't round off. Anywhere in your work, nowhere in your work should be rounded off. So if you use your calculator, that's fine, but it should have the ending going on forever there, okay? If you're doing it by hand, you can move your decimal 3 places to the right. So 42019 decimal place. 42019 decimal place 439439439443, and you can write out as many 943s as you want after you get your pattern going. So we multiply by 1,000 because we had 3 decimal places that were repeating, and now we put n underneath that and subtract. So my n was my original number. And as we put our original number underneath to subtract, make sure you line up your decimal places. So my original number was 42 decimal place, so I'm put the 42 under the 19. 42 decimal place 01943943943. So if you line up your decimal places, the ending there, the 943s, should line up as well on the right. So we're going to take the 1000n and subtract 1n, and this is going to be remarkably beautiful because the numbers line up. Okay, you remember how you subtract? You take the 3 minus the 3, the 4 minus the 4, the 9 minus the 9, and so on. These are all subtracting, even in the dot, 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 because I know the next digit here is a 9, and the next digit here is a 9, and the next digit after that's a 4, and so it is below. So these repeating sections subtract away. So the 943, 943, 943 there is gone. So this part's gone. Okay. The rest I'll go ahead and do by hand. You could take your calculator out if you wanted, and you will need it eventually in here, so you might want to grab it. So you could now take the part that wasn't exactly the same on the top and bottom and subtract. 3 minus 1 is 2, 4 minus 0 is 4, 9 minus 2 is 7, 11 minus 4 is 7, 9 minus 0 is 9. I borrowed from the 2, so there's a 1 there. I'll just check my arithmetic. 2 and 1 is 3, 7 and 2 is 9, 7 and 4 is 11, 1 and 9 is 10, 1 and 1 is 2. Okay, arithmetic checks out, or you can check it in your calculator. So because we chose to multiply by 1,000, these lined up perfectly. And now we have an equation that's much nicer. It doesn't go on forever. Here we still have a decimal place. That doesn't always happen. Okay, but when you still have a decimal place, at this point you would multiply to get the decimal to multiply away. So there's 2 decimal places, so I'm going to multiply both sides by 100. Remember, whatever you do to one side of an equation, do to the other. So we're doing the same thing to both sides of an equation. We're multiplying by 100. So 100 times 999. Move your decimal place 2 to the right. You get 99,900 times n. The next line, the 41,977.42, we multiply by 100 as well, and that moves your decimal 2 places to the right. So now it's to the right of the 2, so I'm not going to write it down. We have 4,197,742. We're almost there now. We just have to divide out the number in front of n. So we take both sides of the equation and divide out 99,900. And there's our result. The same value as we started with, only as a fraction of integers. 4,197,742 is equivalent to 99,900. I'm going to show you that in the calculator on screen since I didn't bring my calculator. So the 4,197,742 divided by 99,900 gives us our original number. The last digit there is rounded by this calculator. So it would be a 3, except the digit afterwards is a 9. So this calculator rounded that up. So our goal here is to write decimals that repeat as rational numbers in the form of a fraction instead of a rational number with a repeating right end. So we'll write down the steps we took in order for you to be able to go back and duplicate this. So we name our number that we're working with n. And then we multiply by 1,000 or however many zeros we need there. We might multiply by 100 if only 2 digits are repeating. We multiply by 10 if only 1 digit's repeating. We'll see some more examples in a minute. So multiply, okay, and then number 3 is to line these up. Maybe we should put the 3 right where you wrote line up the decimals and then call 4 the subtracting, okay? And we don't have to write line up twice. Okay, so number 3, line up the decimals. And 4, subtract. Make sure as you line up the decimals, you're saying what those are equal to. This step 5 where you multiply by 100 to remove that decimal place, that only happens sometimes. Okay, so we'll say 5 sometimes. It's whenever there's still a decimal on your right hand side there. And then 6, divide. And then these are wonderful because you can check them, okay? So 7 is check. Is the answer you got equivalent to what you started with? Only written in a different form? Okay. Well, let's try another one. Does anyone have questions on the first one? You might want to put practice for the quiz. This is one of those things on the quiz that will be worth more points because it does take practice. Okay, so there's several things we worked on this week that take practice. On Monday we'll be reviewing for the quiz, so you can go online and print out the review sheet from Canvas and bring it on Monday. You don't have to, it's just nice to write on it. Yes.
We I got an email for the study session on Monday, but
Mhm.
I don't believe it said where it was.
Oh, okay.
Yes.
Yes, 3:16 for the study session on Monday.
Thank you.
Sure. And I'll remind everyone again on Monday. Let's go ahead and try another one of these. Let's write 52.14141414 repeating as a fraction of integers. So we'll try and follow the steps, and if your steps need clarification, you can write them in then. So the first step was to name our number. So let's name our number. Let's name our number n. Second step was to multiply by 1,000. 3 zeros. Is that right on this one? No. Good. What do we multiply? 100. Yeah. Good job. Yep. Okay. So two numbers are repeating. So multiply by 100 with 2 zeros. Two repeating decimals, 1, 4. So multiplying by 100. So you can use your calculator if you want to. But again, don't round off. You know what the pattern is, so keep writing it out. Multiplying by 100 moves the decimal place 2 to the right, so we have 5,214.141414. Dot, dot, dot. Number 3, line up the decimals. Okay, so I'm going to take my original number, the smaller number, and write it underneath the larger number. So that was named n, so we'll write the whole equation down. N equals 52.14141414 dot, dot, dot. So number 4 is subtract. So let's go ahead and subtract. This is a 1n that we're subtracting. 100n minus 1n is 99n. On the right, now if these don't line up, these 4s and 1s that are repeating, if they don't line up over top of each other, you've made an error somewhere, and you should go back and figure out what happened. They don't all have to line up. Notice up above, only the right end had to line up. Because that's how we know that this dot, dot, dot is actually subtracting away. Okay, 4 minus 2 is 2. 11 minus 5 is 6. I borrowed a 1. So 5. Anybody else get 5,162? Okay, great. Step 5 was to multiply sometimes when there's a decimal, but this time there was not a decimal, so we don't have to worry about that step. So we're on our last step besides checking. We can go ahead and divide both sides by the number. Here we have the number in front of n that we divide by, so 99 in this case. And last is to check to make sure 5,162 divided by 99 is the number that we had originally as a decimal. Where'd my calculator go? And there it is. So because this is something new and a little tricky, I'd like to make sure you know how to do this well. Does anyone have questions before I ask you to work one out at your desk? Yeah.
So I don't know why I'm like not getting it. So what do you like u times 100? How do you get like the 5,214? Like the top one?
This number?
Yeah.
Okay. So put this in your calculator for as many decimals as you can,
Okay.
and then multiply times 100.
Oh, okay.
Okay. Any other questions? And when you do that, you'll get this 5,214.1414. Okay. All right, then I will give you one to work out here. Does someone want to make up a number that ends in 2 repeating decimals?
3.67.
Repeating?
Yeah.
Okay.
6, 7, 6.
Okay. Okay, very good. Here we have this to work with, right? 3.6767 repeating as a fraction of integers. And then if you're stuck, raise your hand. Nicholas and I will work it out quick, and then we'll come around and give you a hand if you're stuck. Or if you feel like you have the answer, raise your hand. We want to make sure you know how to do this. I'm going to keep sending this around. It's still very heavy. I don't like that. Nicholas, make sure you
Hey. Hey. Yeah, I figured it out. Ignore it just so how I did it was I checked my multiple, so I did like 9 times 2, and I see if I added that, so 9 times 2, and I added it to 219 to see if it got me to a 0 at the end. And finally, 9 times 9, 81, add 8, that gets you 300, so you make your odd 10. Does that make sense? Yeah? Yeah, I'm going to do the same thing over here. Oh, this one was easy. This one was just times 2. 2 times 9 is 18. Add all those together, you get 170.
The remainder is 2, and I plugged that in, and it said it was wrong. So,
No,
well, I'm saying why they said it was wrong.
well, it says if you added 18, this should be 170. There should be no remainder. Because 170 is 18. We can update it.
So, for the missing digit, that should be 0.
Oh, you're missing 0.
Yeah, that's what I'm saying. That's why I just said that was wrong, and I plugged it in. That could have been the error.
It's right here.
Okay, nice. Nice.
Here's a question on different, so she did this one, and when she plugged it in, it turned out to be wrong.
I know I plugged in 2 on this question, and I was just wondering if that was the error, because it should
Oh, I
have
got it.
been 2.
It's catching. Is this the day alone? Oh my god, I forgot. There's no way this is today alone.
40.
It's over 20. Yeah.
94.
What?
94.
How did you two so far?
139.
I had it since like around it came out.
So you need something that
like
can
a sound
speak.
like
It does seem like it's
oh, this is
too.
okay.
Yeah.
Then I come back and
Sound like a blue.
Because you got the same thing, right? So, check and see if you wrote this down right. And if you did write it down right, please email me and we'll figure it out.
Well, at least I figured something out.
like I don't want to.
That means I get stressed.
Well, it's not well, that and it's freezing outside. I wonder if I'm allergic to peanuts.
I think I'd save one try.
Just
I don't think
shut
it's
up.
any, so maybe we should have her redo it for us. Is that a thing?
You can develop allergies in real life.
I was trying to think what they're like. I've seen it happen.
It's stuck in my head.
I'm not saying.
Are you excited for the new season?
There's a 99%
Oh, no, same. Yeah, I always
Followers?
Yeah, no, I've had friends for over a year without knowing their name, and that's what you can't ask. Yeah, that's, yeah. Then it's like weird to ask.
I'm gonna say this when I drive home.
Know my name, but I'm just like,
I don't know why, but I don't. I'm gonna keep this on my way home.
I love you. I don't know your name, but
I
I
forgot what this one was. Thingy.
It's
6.
six, yeah. No, wait, 2.5. Nope, 2.4.
Yeah. One time I worked in
2-4.
Yeah, 2.4. 2.4.
I would not know.
Okay, well, that's nice. Okay, so this one
Should be 9.
this one.
3 hours. I'm exhausted.
Hey, well, you just have to do 3. At least I helped you with that one. I can see what you did wrong in the other one if you want.
See, I used to go to
I said this one.
Oh, I did wrong in a while. I think you do the others.
And I haven't, yeah, the other one comes to left.
I hate it.
Does anybody have questions?
She's saying.
These questions.
So when you multiply by 100, then your decimal move 2 to the right. Because there were 2 zeros you multiplied by. So put the smaller value on the bottom. And if you multiply correctly, your 6 sevens that are repeating here line up.
I might have actually eaten the hungry.
And the last step is to divide out the 99. So you should have gotten 364 divided by 99. But like I said, all of this takes practice, and I'd be glad to go over this with you one-on-one, or you could see one of the tutors as well. Does anyone have any questions? Okay, then reviewing on Monday, if you bring the Canvas sheet, the Canvas review sheet, then you can write right on the sheet, and that's kind of nice. If you don't want to, if you like to just work separately, that's fine too. I'll see you on Monday.
Go get yourself
That's it. I did check that on Miley already and it's good.
It's good now?
Yeah.
Okay.
No, it was a 2. The first try was a 2.
Okay. I wonder,
Maybe they went back through and like corrected anything that might have had an error since that one was, but
yeah, that might be.
I have a question. So I already did 2.7 and you know the due date, and I got
Did you have any attempts left? Oh. No, but I do drop you 3 words, so that can be one that gets dropped, okay? Okay.
Okay.
So I didn't know because it was homework. And I'm